Okay, let's start up. This is part C or part 3, depending on how I labeled it. I can't remember. We are up to number 27, and I did find out on number 24, which would have been my previous video, that was supposed to have been an x to the 20th instead of x to the 30th. The concept is the same, but I couldn't read it, so I apologize. Number 27, it is 18x cubed y, and all that is in the radical. Sorry. I had to write it down. Minus the cube root of 16x to the 4th y. Super sloppy, I apologize. Okay, this is a square root, this is a cube root. They cannot be combined, but they can both be simplified. So the best thing to break square root of 18 down to is the square root of 9 times the square root of 2. For your exponents, you divide the power by the root. This is square root, so we're going to divide 3 by 2. That's going to be 1 remainder 1. So 1x is going to get out, 1x is going to get stuck, and I can't do anything with that y because I only have one y. In order to take the square root of anything, you have to have at least 2. Let's go ahead and do the cube root. The best thing to break 18 down, if you're talking about cube roots, would be the cube root of 8 times the cube root of 2. Once again, I divide my power by the root. So 4 is divided by 3. That's 1 remainder 1. 1 gets out, 1 gets stuck. And for the same reason here, you can't mess with the y's because if you're taking the cube root, you would have to have at least 3. So let's see. The square root of 9 is 3, so I'm going to scratch that out and put it on the outside, so 3. A 2 gets stuck, so I'll go ahead and draw my radical and put a 2 on the inside. 1x gets out, 1x gets stuck. The y didn't have a chance, so it's stuck as well. And that's it for that particular square root term. Now we'll do the cube root. The cube root of 8 is 2. So again, I'm going to put the 2 on the outside. I'll go ahead and draw my cube root. Make sure you put a 3 in the crack because if you put a 2, it's a different problem. We said that 1x was going to get out. We said that 1x is going to get stuck. There's also a 2 stuck, and there is a y stuck. Now, this looks like we could combine this. These very much look like terms. I wish they were, actually. This is a kind of wonky problem, but they're not. They're not like terms. One is a square root, the other one is a cube root. Otherwise, we could put them together. Moving right along, number 28, this is practicing foiling radicals. So it's 2 square root of 3 minus 5 square root of 2, and this entire thing is squared. Now, you cannot distribute the square over addition and subtraction. This is a binomial. Because of this subtraction, that tells me I can't just square the first term and square the second term. Instead, what I need to do is I need to write this problem down twice, and I'm going to FOIL it. Now, personally, I like to make my box, but you don't have to make your box if you don't want to. So I think I'll make a box. It needs to be pretty big because I know I'm going to have some work to do here. You put one term along the top, so 2 radical 3 minus 5 radical 2 along the top, and then 2 radical 3 minus 5 radical 2 along the edge. 2 times 2 is 4. Radical 3 times radical 3 is radical 9. 2 times negative 5 is negative 10. Radical 2 times radical 3 is radical 6. Negative 5 times positive 2 is negative 10. Radical 2 times radical 3 is radical 6. Negative times a negative is a positive 25. Radical 2 times radical 2 is radical 4. Now, I have a little bit of work I can do here. I can take the square root of 9. The square root of 9 is 3. So this is just 4 times 3, which is 12. So in the first box, I'm getting 12. Same thing down here. 25 times 2, because the square root of 4 is 2, is just 50. So in this box, I'm getting a 50. I like the box because the diagonals are usually like terms, and that happens in this particular problem. And same thing goes for these diagonals. These are also like terms because they're just integers. So 20 plus, is that a 50? 20 plus 50 is 62. A negative 10 radical 6 and a negative 10 radical 6 is a negative 20 radical 6. You do not change the radical, you keep it as it is. Okay, so that ends, I think, section 1.2. Let's move on to section 1.3. Adding and subtracting polynomials. This is super, super simple. You were just asked to combine like terms here. So let's write down the problem. Negative 4m squared minus 5m cubed plus 4 plus m to the fourth plus 7m squared minus 2. I can't do anything with that m to the fourth, so I'm going to scratch it out because there's nothing else to combine it. I can't do anything with that m to the third because there's nothing else, so I'm going to scratch it out. Now here I can combine my m squareds. I have a negative 7m squared and a positive 7, I think. Okay, those are both m's. Those are both m's. So that's going to be positive 3m squared. Once I've combined them, I like to scratch it out just so I can see what's left over. And the only thing remaining is a positive 4 minus 2, which is negative 2, or subtract 2. Moving right along, number 33. The only difference here is that this negative needs to be distributed across everything in the parentheses. So each of these little terms is going to get a negative distributed to them. What that's going to do is it's going to change all the signs. I think I'll do this one up here. We have 2xy plus 3x, and here I go distributing. This is going to be negative x squared y. This is going to become a positive 6xy. This is going to become a negative 3x, and then a negative times a negative is a positive y. And then you just add your like terms. So 2xy plus 6xy is going to be 8xy. I'll scratch those out once I've used them. Let's see, we have a positive 3x and a negative 3x. Those are going to cancel. Positive 3 and negative 3 cancel. There's nothing I can do with that 8x squared y, and it happened to be a negative, so I just keep it. And same thing for that positive y. These are not like terms. Okay, so you can't combine it. Number 35. Number 34. Sorry, let's make this number 34. This is a FOIL problem, x squared plus y, and 3x minus 4y. I hope that's a 2, but again, my eyes are bad. I'm going to FOIL this one without the box. So x squared times 3 is 3x squared. The outer would give me negative 4x squared y squared. The inner would give me positive 3y, or sorry, plus 3y. Plus 3y. And the last would give me negative 4y cubed. And there's nothing you can combine there. This is one of those wonky problems that the book decided to make up just to be aggravating. Most of the time when you FOIL something, there will be some like terms. But if I read that correctly, x squared plus y, 3x minus 4y squared, there's nothing that will combine there. And the last one in this particular type of problem, which is distributing, you have a binomial a plus 5b times a trinomial 5a minus 7ab plus 2b. Now, I definitely like to make my box here because this is a bi times a tri. And so I'm going to put my binomial along the rows. And I'm going to put my trinomial above the columns. And I'm going to fill in my box. That's going to be 5a squared minus 7a squared b plus 2ab. This is going to be 25ab. This is going to be negative 35ab squared. And this is going to be 10b squared. Again, this is a wonky problem. I don't see any, this will combine. This 25ab will combine with this 2ab. So otherwise, I don't see any like terms. So let's just write down what we've got. 5a squared minus 7a squared b Put those two together, and you're going to have 27ab minus 35ab squared plus 10b squared. Now, you could have a different order than me right here, as long as you have the exact same terms and the exact same signs. Moving right along, number 36. This is a factor problem. 8x squared y squared plus 4x cubed y minus 12xy squared. I have learned a lot of things already. Number one, I can't see, and number two, I cut and pasted this way too small. So I'm having a really hard time seeing these exponents. I hope that is correct. I actually think this is a 3 on that x. I think this is 8x cubed. I think this is a 2. I think that's a 3. I think this is correct. Okay, so we're going to state the GCF. That's all I can do here. The largest of the coefficients is 4. They all share a single x, and they all share a single y. So my GCF is going to be 4xy, 4xy, 4xy. So you state your GCF. And then I had 3 rules. Take it out. That's what I just did. I'm going to take it out of all 3 terms. Number 2, I'm going to put it outside of parentheses. There we go. It's outside. And then rule number 3 is you bring down whatever is left over. So this is going to leave me with a 2x squared y plus a 1x squared minus a 3y. I am so hesitant about this because I really cannot see those exponents. I apologize if this is not correct. I know my work is correct. I don't question my work. I'm questioning whether or not I copied the problem down correctly. Okay, we've got time maybe for one more. Number 37. It's 2x squared plus 6x minus 5xy minus 15y. Excuse me. This is a factor by grouping, and you have to make sure that you take that middle term. This is a negative, and it has to go in that second set of parentheses. So group your first 2, group your last 2, make sure you take the sign in the middle. Okay, then you basically do the GCF with each. So the GCF for 2x squared and 6x is 2x. The GCF here, now this is extremely important. If your lead sign is a negative, ever, okay, even when we start talking about imaginary numbers, if your lead sign is a, if your lead sign is a negative, you have to take out a negative. So I have to take out some kind of negative right here. And it's going to be a -5 and a y. A -5 and a y. If you do not take out a negative, your parentheses are not going to match up. So we're going to take it out. We're going to put it out. And we're going to bring the leftovers down. That's going to leave me with x plus 3. We're going to put this one out, which is a -5y. And we're going to bring the leftovers down. That's going to leave me with positive x and positive 3. See, if I had not taken out that negative with that 5, the parentheses would not have matched. This is how you know that you're right, is these parentheses are identical. If they're not identical, you messed up. So I said you take it out once. In other words, take that parentheses out one time. Cross it out twice. And then bring what's left over here and here in the order that it was left over. So a 2x was left over at the front. It should be at the front. A subtract 5y was left over at the back. It should be at the back. That is a factor by grouping problem. So we just reviewed factoring out the GCF, and we reviewed factor by grouping. I'm going to have to stop. I'll be back with another video.